Hello, everyone, and I wish you are doing great. So, time flies and it's really super quick. So, we are coming to the last chapter in this class. And so, just as a reminder about what we are doing now, so we have already covered almost the whole software life cycle. We talk about like requirement engineering, we talk about design, we talk about testing. We also talked a little bit about coding in that context. And here, maybe again, I will open the parenthesis that this is not a coding class, like I mentioned before, but I encourage you guys, if you have time, even after taking this class, to go for coding a little bit when it comes to your projects. What you did is really great. I'm really impressed with your hard work and the different steps you submitted so far in the project. So for all the teams, I'm really very proud of you guys and just excellent work for everyone. So I see potential in your work, and I see that for students who want to work on their CV, who want to maybe pursue this like path of software engineering towards being software engineers. So it's very important to build your profile. So just I'm opening this parenthesis like it's an advice for your career path. And if you need more discussion with me, always available for you. Okay. So even after the semester, by the way, what I want to say is that coding is now accessible mainly for everyone, I would say, especially with generative AI and ChatGPT or DeepSeek or these amazing, like helpful AI tools. So, what I can suggest if you want to work on your CV, for sure, don't forget to mention this experience of doing this project in your CV. It's a very valuable, thing that you guys did. So you can mention that in your CV in the project section. So I did this or that, or like you mentioned the name of your project and the team members and the duration as well. These people really appreciate while hiring if you're interested in getting a position, even in the future. Coding now, when it comes even to the job market and all, what I suggest people always check your LinkedIn, and they may check also your GitHub where you publish your code. So if you will give some time for coding things or even writing about your project, what you did, I didn't want to put also burden on you guys and say you must share this and make it available on Git, but if you want really to do it will be great. So I encourage you guys for your portfolio and for your like CV, okay? This is for coding, which is not part of this class, but if you will do, you are almost there, okay? Uh, so what now is probably missing in the whole life cycle of software development life cycle is mainly the quality assessment, okay? The quality assessment part is missing. And now we are going to talk about the quality assessment of your software. Okay. So in general, this is the main topic of today, lecture. Okay. So mainly what we will discuss today, we will discuss two big points, I would say, or main points. The first one is we're going to define what software quality is, and then we will see like how it can be measured, okay? And so how to quantify, I would say, the quality of a software, okay? So of course, when we talk about measuring software quality, it's generally done before or after delivering the software, or if there is maybe a new release to the customer, okay? So basically, we must evaluate the quality of our code before releasing it to the customer, okay? And uh, like basically, in order to measure software quality, we need to use metrics, right? And software quality metrics are well defined in software engineering. So it exists already, the definition. This is what we will go through today. So there are many metrics that could be used, but in this lecture, I will mainly cover the ones I would say that are most widely used in practice. Okay. So if I ask you these questions, like for example, how big is your program? Probably like for this, one natural answer would be it's huge, or let's say it's very huge. And it's a very natural like answer in general. Or maybe I have another question. It's how close are you to finishing? Uh, I mean finishing your coding, okay? So you may say, oh, we're almost here, or you may like see that this answer are more or less like you can see now. It's kind of subjective answers because huge could be, I don't know, huge also could be millions of lines of code for programmers with some level of experience. Probably for juniors, it could be undone. So this word, we don't know, okay? So huge could be if, for example, for some intermediate level, maybe hundreds of lines of coding, okay? So there is no accurate, I would say, answer. Then, when you say also, for example, we are almost here, that, uh, what does it mean? For example, it could be hours, it could be days, it could be weeks, or it could even be months. So we don't know exactly, and that's why it's important to find a way to quantify uh, the quality of the software, because we need to avoid this kind of subjectivity when we are actually talking about software like qualities. So when we talk about the size of the project, for example, it may be not helpful to say like it's huge or it's medium. And when we talk about if you are finishing or not yet, also it's not like practical to get answers like we are almost here. Okay, cannot also like let's say as manager accept, I would say, this kind of subjective informations. So it's better to say, like, for example, how many lines of code are there in your project? So to be specific, okay? And these are kind of information. If you will give me, maybe I will have a clearer idea about the quality of your software and where do you stand so far, okay? So this is the recommendation and these information that we need for quantifying, let's say, the cost, the effort, the size of your projects, and so on, okay? And here, so the concept of quality is not limited to only the software, as you know. And so you can think about any, I would say, or any everyday object, and let's say, for example, a chair, okay? How do you measure the quality of a chair? You can think of this. And so you can look at it from multiple dimensions or point of views, okay? Like, for example, you can think of the construction quality, the fit of for the purpose, or how comfortable is this chair, okay? You can even think of its elegance and so on. So many like features or criteria. So there are multiple dimensions, in short, where we can measure the quality of any everyday object, okay? And the same thing applies for the software. And so we can use different metrics, like, for example, like I mentioned before, the number of lines of the code, okay? The number of requirements could be also possible, number of functions, or we can even think of the number of classes itself. So there are many metrics that could be defined. And one challenge, we are like using these methods in case like they are very relative in general, and there is mainly no absolute scale, okay? For example, if we say, I don't know, A is better than B, okay? We cannot say how much better it is, okay? So this makes the concept of quality metrics in general on like hard to make an interpretation from. And one way to do that like is basically to try to do some kind of what we call benchmarking. Like you can compare your metrics to other like project and see, for example, how far you are. Okay. Something I usually did, because mainly in all my like teaching, during my whole teaching experience, I have this kind of uh, PBL, pedagogy or approach, project-based learning. I give a project to the students, I let them work on that project the whole term, and I keep teaching things. And so the students are mainly having something to do, like a hands-on activities for their future, for their CV, for their LinkedIn, and so on. And always this is appreciated. And I love the feedback of my students, like from zero, how we go through the putting things into practice, and we feel like we did something. This is what I always hear back. So I feel very happy always for my students, but the thing that takes a lot of my time is the evaluation. So when evaluating, and mainly sometimes I did this with the jury members and so on. So in general, if we have different jury members, how we evaluate things, we, let's say, have 5 groups, and at the end I have 5 projects. So usually I select their top 5 because they're always top, okay? Like you guys did a great job. So I select the top 1. Then I go for top 2. There is always 2 or 3 projects who I cannot choose between. And then there is the, like, let's say the less quality project, but which is still very high quality yet. So I do things like I try to order, like based on the competition. It's like a pool, and then I do like that. And now in this case, it's very difficult for me because most of the projects, or let me say all of the projects, are excellent, okay? So it's very difficult to quantify, especially if I given like something and the output from the projects, whatever I requested, maybe presented in an excellent way. So just a parenthesis to just tell you how hard it is, and at the same time to express how proud is me with your deliveries and quality of your projects. So now let's come back to our like slides. And so you can think of everyday life activities like I'm mentioning right now. When we want to measure the quality, like for example, for your case, let's suppose that you now want to measure the quality of your work, the quality of your living, for example. And in this case now, you can like use some metric, let's say like the cost of living or the utilities. You can think of like groceries and so on, okay? If you want to measure now the quality of your college experience, okay, you may use like the amount of time you given to properly learn from this class, for example. Uh, your grades maybe reflect. And you can use the number of courses that you are taking at college level, I would say, for example, or even the number of hours of sleep last night, because there is some correlation somehow. So if you want to measure the quality now of a travel experience, let's say you are traveling and you want to evaluate or measure the like quality of your traveling experience, okay? So mainly like in this case, you can calculate the number of miles that you traveled per day, the cost of the meals, the number of connections probably in your flight. So everything should be quantifiable in general, okay? And so now when we talk about the software, it's the same thing. We want to measure like productivity of the programmers. Like for example, we want to measure or the number, let's say, of requirements, okay, that are implemented, the number of changes that they made to the code, refactorings, okay? We can also measure the quality of the code by looking to number of lines of the code, number of functions, and so on. So in general, we need to have this like quantification of software quality in terms, I would say, of metrics, okay? And now, before getting into more details about giving you examples of metrics, let's probably define what is software quality first thing. So software quality in general is defined as, I would say, simple, okay, way, or I will give you a simple definition, okay? So it could be defined as uh, let's say mixture or requirements, like how much like your goal is actually for meeting the requirements of your customer. And probably a naive way to define software quality is by, I would say, saying lack of bugs or high liability, or like, but of course it's not a formal definition, okay? I'm trying just to um, simplify things and so on, okay? But now basically, like, if I define the software quality, I can define it as the degree to which the system component or process, I would say, meets specific requirements. And it's also, I would say, consider it as the degree in which the system component of, like, I would say, process meet customers, or maybe also the using experience, okay? So this is mainly the idea, and it's all, let's say, about meeting the customer expectation and making sure that your software is mainly behaving as it is expected or anticipated, okay? So now when we talk about quality, that also involves for sure the non-functional requirements. And when I say non-functional requirements, like for example, the execution time, the performance, so in general, we can also consider the memory usage and so on. So they are all in general used to define software quality in your system, okay? The now ISO 9126 is like international standard for the evaluation of the software. Okay, so already there are some norms and some existing standards that can help in the evaluation of your software, I mean, in terms of quality for sure. So this ISO 9126 actually defines several, I would say, generic quality attributes that could be applied to evaluate the quality of any software, like for example, reliability, which means the amount of time that the software is available for use. Also, the usability, which is, I would say, the easy or how easy is like to use the graphical user interfaces of your software. Also, the efficiency, so it's the degree to which the software makes optimal use of the system resources. Mainly you can also find the maintainability, which is the time, I would say, to fix any bug that was discovered when like finally we can also consider the portability, which like is how easy to adopt your software between, for example, I would say multiple operating systems, okay? So these quality attributes are formally defined, like, for example, we have the uh, reliability. And here, reliability, like, is mainly in general used in order to check the completeness of the inputs and the consistency, okay? Also, we have the reliability, it also like checks, I would say, the robustness of your system. And the robustness means if like your software, I would say, behaves well under kind of unexpected or abnormal conditions, okay? Like what happens if something wrong is happening. Is your software still robust or not? So this is mainly the idea for reliability, okay? And then we have the efficiency. So it's more about resources like memory usage, like execution time, and so on, okay? Now, maintainability also we have. So it's mainly how easy to fix and add, I would say, new requirements for your software in the future or in the new release, okay? For the usability, now it's how easy to use your software for users, okay? So for each of these metrics, now what we need is that we need to first, I would say, define software quality attributes. Then we have to define, I would say, software metrics. Okay, software metrics means like the number of lines of code, like the number of, I would say, let's say, people or how many person you have per days who are working on the implementation, I would say, of a given use case, fine? So all these metrics need to be quantifiable and should avoid any confusion of being subjective, okay? So we should use terms like I mean, terms, for example, like the examples we given is the start, huge or big or large. These terms we shouldn't use at all. So we need to have a different way. We need to have, let me say, kind of a quantification of this like quality, right? So there are two categories of quality metrics in general. Okay, there are some direct, I would say, straight measures, and some others which are kind of indirect measures. Okay, we start with the first one. So the direct measures, they are, I would say, in general calculated. Okay, directly we can compute or computer calculate them, like for example the number of code, like duration of the process, the number of defects, I mean number of lines, okay, the length for the length of the source code, it's the number of lines in your like code, okay? Duration of the process, number of defects discovered, and so on. So these are what we can measure directly. However, there are also, what, like I mentioned, the indirect measure that are a combination of the direct measures. Like, for example, if I want to calculate the function defect density, for example, I'm just giving an example, okay? I will use in this case two probably direct metrics for this, which are, let's say, the number of defects discovered divided by the timeline of how much the software was running, for example, okay? So this is like indirect measure computed, let's say, given few direct measures, okay? And so they are in general a combination of multiple, I would say, atomic or direct metrics. So some examples of metrics that are widely used as an object-oriented programming. Now we take this case, and I know maybe many of you took some object-oriented like programming course. What we have in here, for example, is the number of children of a class. It can represent, for example, the number, I would say, of subclasses, okay? This could show an indication of how easy it is to reuse your software. So if, let's say, you increase the number of children, what does that mean? It means that your software, let's say, has high reusability, okay? Let's take another example or of metric for sure. So this example is the example of coupling between classes. So again, in the same context of object-oriented programming, okay? So the idea is like coupling between classes, okay? So the coupling is defined, I would say, as the number of like function calls existing between two different classes. So this is what we call coupling. And also cohesion is actually, in this case, the idea of having completely the opposite. So it's the number of function calls within the same class, okay? So this is another like metric. So other type of metrics, like let's say the commands, okay? We talk about the command percentage, okay, in your code. So if we consider the whole script, or like your code, so okay, your file where you are writing your code, so we need to look like if you are commenting your code or not. Okay, so the idea is I want to see how much you are commenting, okay, your code as a programmer. And then in general, if we have mainly, I would say 20% of your like number of lines of codes are about commands, this is a good indication that your code is well documented, okay? So the higher the CP, and CP here it's for the command percentage, okay? So the higher the CP value, the more I would say maintainable the module is, okay? But of course, so when we talk about these metrics, there is no consensus about them, okay? And also, there is no generic way to define a thousand, I would say, of how we say this is good or this is bad software. So, in general, the best way to do this is to actually do what we call benchmarking. And the idea is here, like I mentioned in the start, is to compare between two projects, and we see how far you are like from your project is from other projects. Okay, so this is how I work for your evaluation, by the way. And what is shocking me for like all of them are excellent. Good job. Okay, let's back to our um, slides. Now, another issue that we have maybe is that software manager have to deal with it mainly in practice, this problem, okay, or this issue. The issue is that what metric they have to select. It's very important. So let's suppose that we have already the metrics defined. We have a huge list of defined metrics. Which one we will go for, okay? So there are in general, I would say, like multiple metrics, and they can be used, okay? They can be even, the problem is that this list I'm talking about, or this metric, they can be conflicting, okay? What I mean by conflicting is mean if I, for example, want to increase, let's say, something, it's automatically I find the other thing is decreasing, okay? Or if I want to minimize something, and the other hand, something there is getting like maximized, okay? So this is the idea of conflicting objectives that we, or it's not we for sure, it's maybe the software managers can face, okay? So basic metrics, let's say, include size, cost, duration, effort, quality, and so on, okay? I mean the quality in terms of number of faults detected, absolutely, okay? So one challenge is which metrics are the important ones, okay? And for that, several like companies try to, I would say, define a model for assessing quality of their software system. So mainly this is the idea. And one of them, I would say, is the goal, question, metrics model or approach. And here what happens is like you can actually define your goals in terms of what quality attributes you want to improve, and then for each of these like quality attributes you can define some lower level metrics that you can use. Like if we talk about reliability, for example, you may use different metrics like simplicity, like modularity, um, and let's say then you can define which low level metric you could be used, like let's say execution time, the number of bugs that were observed in, like, and so on. Okay, so you can actually kind of decompose, I would say, your quality metrics in terms of aggregation of atomic metrics that can like actually define your quality model. Okay, so according now to the ISO 9126 standard, it's the software quality is defined using a kind of generic hierarchical like model. It follows divide and let's say conquer approach. Okay, and the idea is like to breaking quality into characteristics or sub characteristics, and finally let's say we are breaking them into simple measurable metrics at the leaves. Okay, so the basic metric allow us to evaluate the software quality in clear and objective way. But now let's see the counterpart. So although here, like for example, this is an example, and although there is generic model form, which is this one, the I ISO 9126, there is almost some flexibility to define your own quality model. Okay, so there is the standard one, still you can define your own, right? So the idea of defining your own quality model, it's like you need to be based on the context of your software quality. Okay, okay, so what I want to say now is that although let's say most of the metrics in practice are defined at the code level, they are not limited to the code level. I don't know if you're understanding. So the idea is that, so like we are defining them in code level, but it's not limited to the code level. You will understand. So the idea is that they are actually related to maybe sometimes design level or even the requirement level. Okay, and in general, they could be useful to evaluate the quality of your design and not only your code. So this is the idea. Okay, so some metrics that could be, let's say, defining the requirements that could be I would say at the requirements level. Okay, like the number of requirements that change over time, for example. We can also look at the number of inconsistencies in the requirements as well. Okay, it's another important point. So also we can look to at like the cost as well, the cost of your project, and the duration, also the effort, which is the number of programmers who are working on your project, the team members. So we have different metrics that we can define at the requirement level. Okay, and the same thing when it comes to the design level, because as you can imagine, for example, if you think about, let's say, the example of class diagram. Okay, so many metrics could be defined in this context, like you have the number of classes, the coupling, the cohesion, the systematic complexity, for example, the calls between classes that are represented with association and so on. So this mainly the example, but in general, there are multiple methods that are defined, especially for object-oriented programming. Okay, and also let's say that some of them, like the weighted method per class, just an example. Okay, it's like basically kind of the number of methods per class. Of course, like having a class that includes, I would say, a large number of methods could be kind of like prohibited. Like in general, we don't suggest that. So we want to reduce the number of methods. Okay, also let's say the depth of the inheritance. Okay, there it's another type of metrics that actually correspond to the number of children in your tree, and this number of children maybe shows the depth of your tree from, I would say, multiple levels. And this could be used to measure the readability of your code, okay? Also, we have the, like, maybe there are kind of, I would say, even simpler metrics, like the number of lines of code, that actually, I would say, it can show the complexity of your project as well. Here also, like, you can define some other metrics like number of attributes, like number of hierarchies, and so any quantifiable, I would say, metric could be useful in general to show the complexity of your project and its quality. So some of the most common ones, as I said, are coupling and cohesion. And so coupling group isn't the number of calls like between classes. It could be a function call between classes, okay? And for cohesion, like it's the opposite, like I mentioned so far, and it is the number of calls between the function in the same class, within the same class, okay? So also we have the uh, another metric, which is the cyclomatic complexity. I think all of you are familiar with it. It's more related to the number of tests needed for branch coverage, okay, of a given module, okay. This could show you, I would say, how difficult it is to test your code, which can have an impact on the future bugs. Of course, there are also metrics at the maintenance level, like the number of, I would say, forms that are reported. I think probably many of you know about Bugzilla, for instance, okay? So that has a repository, repo, where you can have all the lists of bugs that were observed over the multiple releases on like open source systems. And let's say that's why many tools are offering like this visualization support that can actually show you probably, I would say, the best part of the good, or maybe the good part, okay? And what is, I would say, excellent or really good about your project, okay? So this is the idea. Okay, so the idea here, what we have so far is the tree representation, okay? Like visualizing things. So in this case, like what we have this kind of tree representation where you can actually have maybe, I would say, different colors, okay? And so the idea is that by having these different colors, you can also have, by the way, different sizes, okay? And they represent each of your classes, or each of the classes, I would say, of your system as nodes, okay? And the ages in here so represent the let's say the relationship, okay, or I would say the inheritance relationship, for instance, okay. So you can quickly, like this diagram allow you to quickly, I would say, visualize which class is probably, I would say, having larger size, okay? These things that we can visualize here, okay? And many things, okay? So these metrics, like, can be used to evaluate the software quality in general. And it also, it's helpful not only at the end, but I would say throughout the development process, and it helps, let's say, identifying areas for improvement, and to track your progress over time, and so on, okay. I think, yep. Okay. Sorry, there is a slide somehow. Oh no. Okay. We're coming to the last slide. What we can see here is, where is my pointer? So what you can see here is maybe it's a better visualization. And so how it looks like. So I think, or I can see that this it's known as like city metaphor. So this is called the city metaphor because it looks like a city, okay? And this is maybe the source code for your project, and it's presented just this way, where like what you can see here, it's like um, you can see, for example, in red, okay? So these are the classes that probably have very high number of lines of code, okay? And if it's blue, it's less like lines number of code, okay? So this can show you like, or give you an idea about the complexity of your project and your code and so on. And so this is just another way to visualize your code by using the quality metric, okay? So this is a different way. And I think that that's it for today. And so mainly in software engineering, quality metrics are used, let me say, to measure the quality of a software product or a given system. And so let me say quality metrics, they help in determining whether the software meets the requirements or not. And it helps you also probably to answer to the question if your software is performing as expected or not. Also, it helps answering like or addressing like answering, let me say, question about the reliability of your software and let's say efficiency and also the maintainability of your software, okay? So mainly these are the most important parts that we cover today. And I believe in this recording, I try to cover mainly the most important points related to software quality. So just make sure that you like go through the slides and so try to understand things. If something is still unclear for you, never hesitate to ask me or like send me a message. You can send in Discord for the whole group. We can discuss about things. So in all cases, thank you so much for your attention. And that's it. Bye bye.